okay, today I'm talking about arrangements, and this is essentially an extension of the fundamental principle of counting, and it allows us to answer a question that goes something like this. In how many ways can we arrange the letters in the word acerbic? So this word here, acerbic, means something like sour, I think, something like that. So to find out in how many ways I can arrange things or collections, the way I'm imagining I'm imagining this is as follows. I'm thinking that every single letter is a Scrabble tile, and I have all the tiles in a bag. So now, when I'm trying to think about arranging the letters, I'm thinking this. Okay, so for the first letter of the arrangements, I'm picking out a tile from the bag. Out of how many am I picking that tile? How many tiles are there in a bag? There are 8 tiles because there are 8 letters in the word. So for the first place in the arrangement, I'm putting 8. I have 8 opportunities. For the second, how many will there be in the bag? 7. And then I'm going to keep going to the third one, 6. Because you took 1 out already. So now for the third one, you took 2 out. That's why you have 8. Then 5, 4, 2, and 1. And then to get the number of possible arrangements, all you need to do is just multiply those numbers. And that's it. Job done. So that's the arrangements. There is this kind of operation is called a factorial, and it's written like this, 8 with a little exclamation mark. So 8 with a little exclamation mark is 1 by 2 by 3 by 4, 5, 6, 7 by 8. So from 1 to 8. You multiply all the numbers between 1 and the number you get the factorial of. Okay? Sort of, kind of, let's have a look at example. Yes. Yeah, of course. So now, let's take a look. Please, keep it down. So we're talking about how many 3-digit numbers can we form with the following digits, 1, 2, 3, and 4, and 5. So what I know is the first one. I have 3 digits. The first one, the second one, and the third one. So these are my 3 digits. So now for the first position in my number, how many tiles are there in the bag? Okay, so either 3 or 5, right? Because there are 3 tiles in the number, but this is the arrangement that I'm looking at. Arrangement of any of these numbers. So how many tiles in the bag then? 5, right? So for the first position, I'm taking out of 5. For the second position, how many numbers in the bag? There will be 4 tiles because I took 1 out. And for the third one, there will be only 3. So 5 times 4 times 3 is 60. So this is how many numbers, so how many 3-digit numbers can be formed with those 5? 60 3-digit numbers, okay? With those 5, yes. So 60 3-digit numbers can be formed with those 5 digits, okay? So now, the first part of the question is, how many of these numbers begin with 5, okay? So I have, again, I'm going to start the same way as I'm doing these questions. Write my number of digits, number 1, number 2, and number 3. And then these numbers begin with 5. So out of how many letters or numbers am I selecting the first one? How many 5s are there in my, just 1, right? Because you see in the list, you only have 1 5 over here. So that's why I'm only selecting for the first digit. I'm selecting out of 1. But for the second, out of how many? Okay. How many, okay, think about it this way. How many tiles do I have in the bag? I count this number here. So I took 1 out. How many left? How many left? 4, right? So for the second number, 4. And for the third one, 3. Okay? So that will be equal to 12. 12 numbers that start with 5. Sort of, kind of, okay? So, okay, so a couple of examples of those numbers would be 512, 513, 514, then 521, 523, 524, and so on and so forth. You'd get 12 of them. And note, every time, 5 in the beginning. That's what question is asking me to do, okay? 5 in the beginning, and then I'm just selecting out of the bag for space number 2 and space number 3, okay? So how many of these numbers are greater than 4? not 4, but 400. So let me just list the numbers again here. I have 1. Yeah, sure. And again, I'm multiplying here, so I'll just add the multiplication marks. And I'm multiplying here as well. 1 by 4 by 3, 12. I think you kind of get it. Not at all. Okay, so for the second example, I have again numbers 1, 2, 3, 4, and 5. And I'm looking for numbers that are greater than 400, right? So for the second question, I'm looking for the numbers that are greater than 400. So for the first digit, second digit, and the third digit. So think about it carefully. Out of how many girls, quiet please, how many of those digits will give me numbers that are greater than 400? So how many of these digits, if I put them on the first place, are going to give me numbers that are greater than 400? So will 3 be greater than 400? No, right? So in this list, just 4 and 5. So if I put 4 over here, or a 5 over here, that number will be greater than 400, because now we can have 412 or 543. Yeah, something like that. So you're selecting, these are like your tiles with digits, and you're selecting those tiles to put them over here in your new number, okay? So how many numbers that are greater than 400? So for the first position, you can select 2 tiles, a little bit more. For the first position, you can select out of 2 tiles, okay? Out of 4 or 5. For the second position, you have 1 tile away, because 1 tile is gone here for this one. So 4 is gone to this number. Then for the second position, you have 4 tiles. And for the third position, you have 3 tiles. Okay? So 2 times 4 times 3, 24. So there are 24 numbers that are greater than 400 that we can make with those digits. Do you need to take this one, Alicia, as well? Yeah. Okay. Yeah. I'll be putting all this up on the OneNote as well, so you don't need to take the photos if you don't, you don't need to take photos. It's all going to be up on the OneNote notebook.